Alright, so we're going to be talking about aldehydes and ketones. Aldehydes and ketones both contain a carbonyl group, but where that group sits on the carbon chain determines everything about how they are named and drawn. So what is a carbonyl group? So both aldehydes and ketones have that group. And what it is it's a carbon double bonded to oxygen. So that is the carbonyl functional group. So the difference is the position. In an aldehyde, the carbonyl is at the end of the carbon chain. In a ketone, the carbonyl is within the chain, not at either end. So if we have a carbon chain, it looks like this. Then because that carbonyl group is on the last carbon, that means that this is an aldehyde. All right, but if that was on the middle carbon, so if it looked more like this, then it would be a ketone because we have the functional group in the middle. Okay, so that's the difference between the structure of them, and they also have different naming as well. So for aldehydes are named using the suffix "al." The carbonyl carbon is always at carbon 1, so no position number is needed in the name. So for example, if we have this molecule here, we have 3 carbons, so the prefix is prop, and the suffix is anal, so propanal. Okay, so that's an example of aldehyde. If we look at ketones, ketones are named using the suffix "-one". So if we take the same molecule here, but we put the functional group along the middle carbon, then it's no longer an aldehyde, but instead it's a ketone, and the suffix is "-one". So this one becomes propanone instead of propanal. Okay, so to summarize, both aldehydes and ketones contain a carbonyl group and share the molecular formula CnH2nO. So thus here. So if we have a carbon with, if we have a molecule with 6 carbons, then N would equal 6, and the molecular formula will be C6, H 2 times 6, which is 12, and then O. Okay, aldehydes have a carbonyl at the carbon 1 and use the suffix "al". No position number needed. Ketones have a carbonyl within the carbon and within the chain and use the suffix "-one". A position number is required for ketones usually. All right, so if we have something like this, then that ketone is on the second carbon, so we would say 2-butanone or butan 2-O, both the same thing. Okay, the smallest possible ketone is propanone, as 2 carbons are needed either side of the carbonyl. So we looked at that before. All right.